In this example, we're going to use the models f of x equals 0.074x plus 2.294 and the function gx equals 2.577 multiplied by 1.017 to the power x, the unit in billions, and x years after 1949 to solve the problem. In part A, world population in 1970 was 3.7 million. Which function serves as a better model for this year? So we're going to compare which one gives you the closer number to the exact number of the population in 1970. Um, as we use the function f and the function g to predict the population in the year 1970. X, the problem tells you that X is the year after 1949. So for the year 1970, we're going to compute how many years after the 1949 by getting the subtraction of 1970 and 1949. So the X would be 21, or 1970 is 21 years after 1949. So for X equals 21, the first model or the function f at 21, the value going to be 0.074 multiplied by 21 plus 2.294 and put in the calculator, it should give you 3.848 and don't forget the unit is in billion or 3.8 billion population. For the second one, we use the function g. G at 21 is 2.577 multiplied by 1.017 to the power 21. Put in the calculator. Make sure you write in the order of operation. Parentheses is encouraged to be used for the problem every time you calculate the numbers in a complicated form like this. And the number you should see 3.67159 unit in billions for the model G at the same x equals 21. So the two functions as you see, the first one is the linear. I put a note here. This is the linear model. And this one is the exponential model. Just different form of the model. But if we use both models to predict, the problem in part A asks which function serves as a better model for this year. And the other way we just, they ask you to think about which one gives you the closer number to 3.7 billion. And looks like the function g is closer because it's off by about 0.3, where the first one is off more than 0.03 billion. Okay, so then we put the note here. The function g, the gx model, serves as a better model for this year. And then the next part, by one projection, world population is expected to reach 9.3 billion by the year 2050, which function serves as a better model for this projection. So as in the similar way, but the projection in the year 2050, we have to see how many years after the year 1949. So compute for the X. So X is 2050 minus 1949. That comes out to be 101 years later after the indicated year or the year 1949. So we're gonna check out the same way as the one before or in the previous problem. So look at the function value, the f at 101, or compute the number, replace x with the 101 in the function f, or 0.074 multiplied by 101 plus 2.294, and the number will come out as 9.768. And then for the function g at 101, we have 2.577 multiplied by 1.017 to the power 101. And the number will come out as 14.1426. Okay, as you see in this, with these two numbers, the first one is closer to the projected number, which is 9.3. So in this case, we can say that based on this projection number, 9.3 billion in by the year 2050, so the function f of x is would serve a better model. Because the number 9.768 is closer to 9.3.